In 2024, German scientists discovered a dataset that forced NASA to hold an emergency meeting. Our solar system is racing through the Milky Way at a speed 37 times faster than previously expected. This is not science fiction. It is the conclusion drawn after the LOFAR-Radioteleskop observed tens of thousands of galaxies. What's even more frightening is this: no one knows what is pushing us forward. After physicists spent nights running calculations, they reached a shocking conclusion: if this speed is real, then every cosmology textbook written over the past 100 years may be wrong. Imagine sitting on a cosmic high-speed train, with no idea who's driving, no idea where it's going, and with the brakes completely broken. That is our current situation. One astronomer privately said something chilling: we may never have truly understood our position in the universe. So how was this number measured? Scientists used a method called Dipol-Anisotropie. Put simply, when you're racing through the universe, galaxies in front of you appear denser, while those behind you appear more sparse. Just like running through a rainstorm, where raindrops hit harder from the front. LOFAR observed tens of thousands of distant galaxies, and the result was startling. The density difference was 37 times stronger than theoretical predictions. A team from Bielefeld University in Germany repeatedly checked every possible source of error. Instrument malfunctions, observational bias, data processing issues. All were ruled out, yet the signal remained. The paper was published in Physical Review Letters, one of the most prestigious journals in physics. What does 37 times actually mean? It's like thinking you're driving at 100 km per hour, only to suddenly realize the speedometer reads 3,700 km per hour. Some physicists calculated privately that if this speed is real, we are moving through the universe at over 600 km per second. In the time it takes you to blink, Earth has already traveled several thousand kilometers. The question is, who gave us such an enormous speed? The first possibility is spine-chilling. Perhaps our original estimate of the solar system's velocity was wrong from the very beginning. You need to understand this. Astronomers measure all motion in the universe relative to a reference coordinate system. Just like GPS needs Earth's position to work. If that coordinate system itself is tilted, then every calculation built on it, galaxy distances, cosmic expansion rates, dark energy distribution, would all need to be redone from scratch. This wouldn't be a matter of tweaking a few parameters. It would mean rewriting the foundational logic of cosmology. The second possibility is even more disruptive. Standard cosmology is built on a core assumption that the universe is uniform on large scales, like a well-stirred cup of coffee. But LOFAR's data suggests the universe may be more like a poorly mixed bubble tea, with tapioca pearls clustered densely in certain regions. If that's true, it means that after the Big Bang, the universe evolved in a far more chaotic and unpredictable way than we imagined. These enormous matter clumps would create additional gravitational effects, pulling the entire solar system in a specific direction. There's a crucial detail here. This is not the first time anomalies like this have appeared. Earlier studies of quasars and infrared galaxies had already hinted at similar directional biases, but the datasets were too small to confirm them. Now, LOFAR's observations of tens of thousands of galaxies have connected these scattered hints into a complete chain of evidence. When multiple independent studies all point to the same conclusion, it becomes very hard to dismiss it as coincidence. But there is a third possibility, and it's the most subtle one. Perhaps the issue isn't our motion, nor the structure of the universe, but the radio galaxies themselves. Radio galaxies are special galaxies, whose centers host supermassive black holes that emit powerful radio waves. If their formation and evolution differ from ordinary galaxies, their cosmic distribution could naturally produce a stronger dipole signal. In that case, the anomaly would reflect the complexity of galaxy evolution, not a cosmological crisis. Right now, the biggest mystery is this. We don't yet know which explanation is correct. But one thing is certain. Within the next 5 years, we will have an answer. That's because humanity is about to experience an explosion in observational capabilities. First comes the Square Kilometre Array, SKA, currently under construction in Africa and Australia. Once completed, it will be the most powerful radio telescope ever built, with sensitivity several times greater than LOFAR. If the dipole anomaly still appears in SKA's data, we can be confident it's not an instrumental issue, but the universe itself trying to tell us something important. The Varese-Rubin Observatory will also play a crucial role. Over the next decade, it will map the entire southern sky and record the positions of billions of galaxies. Its data will tell us whether the anomaly appears only in radio galaxies or across all types of galaxies. Meanwhile, the Euclid Space Telescope will provide infrared observations, complementing LOFAR's radio data. Together, these three instruments are like giving the universe a full-body CT scan, examining every detail from different angles and wavelengths. When SG begins operations in 2028, we should finally have a definitive answer. You might ask, does this affect our daily lives? In the short term, no. Earth won't fly off just because the solar system is moving faster. The seasons will still change as usual. But scientifically, the impact of this discovery may rival the moment we first realized the universe is expanding. Think about it. Humanity spent centuries building modern cosmology. From Newton's law of universal gravitation, to Einstein's general relativity, to the Big Bang theory. Each step was built with the lifetimes of countless scientists. This framework explains galaxy formation, cosmic expansion, black holes. It answers nearly every major question about the universe. And yet, LOFAR's discovery is like finding a crack in the foundation of this grand theoretical structure. The building may not collapse, but the crack reminds us that our understanding of the universe may still be far from complete. That is what makes science so captivating. Just when we think we've grasped the truth, the universe finds an unexpected way to tell us, "You're still far from it." Every such discovery represents another leap in humanity's understanding of the cosmos. There's another angle worth considering. If the solar system really is racing at extreme speed, what force is driving it? The Milky Way's gravity isn't enough. Could dark matter be responsible? Or is there some even larger-scale cosmic structure, hidden from our view, influencing the entire local group in unimaginable ways? Scientists have proposed a concept known as the Great Attractor, a massive structure hundreds of millions of light-years away, with gravity strong enough to pull thousands of galaxy clusters. Our Milky Way is accelerating in that direction. But whether the Great Attractor can explain LOFAR's anomalous speed remains uncertain. Some theories suggest there may be structures even larger than the Great Attractor, located even farther away, pulling on us. It brings to mind an ancient question. The turtle carries the elephant carries the Earth. But what does the turtle stand on? Perhaps behind the Great Attractor lies an even greater attractor. And behind that, something even larger still. The structure of the universe may be orders of magnitude more complex than we imagine. This discovery also forces us to revisit a philosophical question. What is humanity's place in the universe? Centuries ago, we believed Earth was the center of everything. Later, we learned Earth is just a planet. Then we realized the solar system sits in a remote corner of the Milky Way. Now we know the Milky Way is only one member of the local group, which itself is just a small part of the Laniakea supercluster. Again and again, we discover we are not as special as we thought. And LOFAR's findings tell us, we don't even know how fast we're drifting through the universe. This sense of the unknown is both humbling and exhilarating, because the unknown means there is still room to explore. And humanity's journey is far from over. One astrophysicist once calculated that, if we are moving at 600 kilometers per second, then over the 13,8 billion years since the Big Bang, the solar system would have raced through more than 260 billion light-years of space. Of course, this calculation is meaningless, because the universe itself is expanding, and space doesn't behave the way we intuitively expect. But the number gives you a sense of how wild our motion is on cosmic scales. The next 5 to 10 years will be the verification phase. SKA will be fully operational by 2028. The Vera Rubin Observatory has already begun test observations. Euclid is sending back data. Together, these instruments will tell us whether the anomaly LOFAR observed reflects the true structure of the universe, or the limits of our observational methods. No matter the outcome, one thing is certain. The universe is more complex and mysterious than we imagined. We thought we had drawn a map of the cosmos, only to realize it may not even qualify as a rough sketch. And that is the most thrilling part of scientific exploration. Tonight, when you look up at the stars, remember that the planet beneath your feet is carrying you at astonishing speed through the Milky Way. We don't know where the destination is, and we don't know how long this journey will last. But one thing is certain. We are witnessing another turning point in humanity's understanding of the universe. Perhaps one day, when we truly understand why the solar system is racing, We will also grasp deeper laws governing cosmic evolution. Or perhaps we will uncover even more mysteries, and realize that the depth of the universe far exceeds the limits of human intellect. This is the story of the solar system's cosmic sprint, a story about speed, the unknown, and humanity's never-ending curiosity. And this story has only just begun.